Good morning, everyone. My name is Aaron Lippold, and I'm the Chief Engineer and creator of the MITRE Security Automation Framework. And I'm joined today with some of my team members on the MITRE SAF, as well as one of my partners in the community, Mike Fraser from the Sophos Corporation. And today we're here to talk to you about containerized security with our talk, A Whole New Containerized World, Building Security into Containerized Applications. We're going to talk to you about some of the challenges we found, some of the solutions that we came up with, and some of the gaps we identified, and where we'd like to go from here. So first thing, I want to talk to you a little bit about what is the MITRE Corporation. The MITRE Corporation is a federally funded research and development center funded out of the federal government in the public good. And we've been working on the challenges of national security and other challenges in information security for the better part of 60 years. If you want to learn more, please visit the Who We Are on the MITRE main website. And now I want to talk to you a little bit about the Security Automation Framework itself. The Security Automation Framework is an effort that MITRE has put together in the interest of the open source community and cyber communities, which is a collection of work and activities and outcomes from the various projects that we've been working with in the defense, intelligence, and federal communities over the last many years. In those collaborations, we've worked with everyone from Progress Chef themselves to help develop the InSpec language, to Sophos, VMware, Rancher Federal, Microsoft, GitHub, and all kinds of other corporations to help enhance and grow cyber solutions and open source security solutions in the community. Mike, do you want to talk a little bit about what Sophos is doing?
Absolutely. So from a Sophos standpoint, I joined Sophos from the acquisition of my startup Refactor, which was we created a DevSecOps automation platform acquired in August of 2021. And Sophos traditionally has been looked at as a endpoint security company, but has evolved over time around being able to deliver security or cybersecurity outcomes across a bunch of different products in our portfolio, a lot of them coming in from acquisition, like my startup Refactor, Capsulate, Braintrace, and the most recently SOC OS, which is a core piece of our MDR technology. And Sophos Factory, we've been working with the security automation framework team here for a number of years back when we were Refactor. And the goal was to really push forward to enable automation across DevSec and Ops teams. And we'll get into that a little bit later here on how that works into this whole new containerized world and what we're doing with the security automation framework team. Thanks, Aaron.
Okay, thank you, Mike. All right, so now that we've given you a little bit of background on who we are, we'd like to talk to you about the challenges and the solutions that we've run into as part of our work on the MITRE SAF team, automating security activities as they relate to containers. So overall, we've been finding the DevSecOps space to be an increasingly containerized world. Both industry and MITRE's government sponsors are deploying applications as fleets of containers, like microservice meshes, right? And this is good. We get all the benefits of containerizing software by doing this. Your dependencies are now all bundled together alongside your application inside a single image, which makes it much easier to distribute and deploy your software, regardless of where it's going to end up down the line. So no more works on my machine. It's also easier to version manage it, tag it, build on top of it, do whatever you want to do when you're working in a containerized environment. But like any other convenience technology, new methods in containerization leads to a new security threat landscape. So we'd like to discuss the following questions that we have been answering for government development teams for the last few years. Namely, what security considerations do I need to take in response to our new containerized world? What has changed between securing a full virtual machine as opposed to securing a container? And what hasn't changed? Furthermore, how do I define what a secure container is in the first place? It's not always obvious. Next, what security tools do I use, and how can I make the best use I can out of them? Spoiler alert, a lot of our answer to that is InSpec, but we have a whole ecosystem of security testing tools for containers, each of which says that it's the killer app for security. So how do I approach using these tools in this new environment? Thirdly, how do I streamline and manage my security processes? Suddenly, I don't have one big system to secure. I've got dozens of microservices, and it seems like every one of them needs a hotfix every week. So how can my team and I burn down security activities faster so as to handle the increased workload? And finally, we want to talk about the gaps that we still need to fill, because we won't pretend that we have completely solved security in the container space. We want to discuss the pain points and the gaps that we still see in this space, so that we as a community of developers and security professionals can account for them and hopefully solve them. So that's what we want to do in this talk. Amdeep, do you want to talk a little bit about our industry collaborations?
Sure. Aaron mentioned it earlier, but we have many official collaboration efforts in industry. First off, we have a really close relationship with Progress Chef because of our heavy use of their tools like InSpec and Test Kitchen. Thanks for being so receptive to our feature requests and PRs. The MITRE SAF has also been fortunate enough to work with Sophos as part of our goal of making security automation practices easier and more stable. Thanks, Mike. It's been a delight working with you. In collaboration with Sophos, Oasis, and others, we've also formed a technical committee underneath Oasis Open for the Oasis Heimdall data format, which is a normalized security data schema. Aaron and Mike co-lead that TC. We'll go into more detail on OHDF later on in this talk, since there's plenty to say about the format. We also want to shout out our friends at VMware and Lockheed Martin, who started out as users of SAF content, but then they liked it so much that they put up their own developers to work with us on building out our toolset and features. Hopefully, we'll have an opportunity to work with y'all in the future as well. And talking about work, the SAF develops and integrates with technologies that can harden and validate the security of software components like databases, operating systems, and web servers. In recent years, we've been seeing more and more questions from our users and partners about how they ought to secure their containerized applications. This is because containers are becoming the default method for deploying software in a complex environment. The security community enjoys an ever-growing list of orchestration management tools built around containerization that are seeing wide adoption, as well as a wide slate of security tools specifically designed for assessing containers, such as InSpec. Nowadays, teams are getting familiar with creating deployment pipelines for containerized software that include enough security testing to generate all kinds of reports on the security posture of their deployment. And that's great.
However, alongside the benefits of containerization, we're also taking on new risk sources. In addition to this, we have to ensure that while containerizing our applications, we don't lose focus. And by that, I mean that containers are not magically immune to the fundamentals of security. The basics all still apply. Basic security hygiene stuff, like your patch and release process, your operations and maintenance, your Dependabot updates, and so on. All of these are still critical considerations for containerization. Sometimes we see teams who think that containerizing their software means that they're off the hook for O&M. This is not true. The sad truth is that a container is really just a wrapper around a service that is running on the container host. And there are many security technologies that help keep the container locked down. But if we're going to ask the question, is my container deployment secure? What we're really asking is my service, host, and environment that I'm going to use to run my app, are all of these things secure? If we don't approach security this way, it's like spending all of our time building the best padlock for our door possible and completely ignoring checking the walls of the house for holes. We also notice, and this is a wider problem than just container deployments, but it's especially prevalent here, is that teams tend to put a lot of focus on running all kinds of cool new scanning tools against their test targets, but they put a lot less focus on building out the human processes for actually doing something with their scan reports. Generating a mountain of security data is good and necessary, but only as long as you can use it to inform your decision making. And finally, on a related note, I just want to point out a trend we notice in our sponsors is that teams tend to conflate container security and CVE scanning. People tend to think that they're the same thing, but CVE scanning, vulnerability scanning in your dependencies, is only part of the story when we're talking about securing a container. You also need to check for misconfigurations, stuff like CCEs, common configuration enumeration, common weakness enumeration. All of these things are just as important as vulnerability checking, because you can have a container that has no vulnerable dependencies whatsoever, but if you deploy it running as root, then you have invited in risk. Now, I know what you're thinking, but I'm generating an SBOM now. I'm so secure. And that's great, but what are you going to do with it is the question we're trying to get you to ask. We sometimes see teams focusing on the letter of a new cybersecurity directive delivered from on high, as opposed to thinking about what those directives are actually supposed to support. For example, the White House released a new national cybersecurity strategy, of which a key part is the generation and use of software bills of materials. And this is important because there have been many examples in recent years of vulnerabilities in dependencies leading to breaches. Engineering teams have responded to these new requests and generated new artifacts, but then they don't necessarily have a similarly robust process for actually doing something with the artifacts that their tools create. It's a disappointing truth, but no matter how many shiny new tools you run in your CI/CD pipeline, you still need to make sure that your team, your flesh and blood human beings, understand and can address the results of your automated processes. No amount of security data is going to get you out of needing to make a security decision. Amdi?
Okay, so at this point, we've talked about some of the challenges that we see with regards to containers. We're seeing more and more people diving into containerized apps, which introduces even more complexity to their already very complex security problems. Now that we're here, what needs to evolve from our legacy security validation processes? And what are the best practices for deploying specifically containerized software? Teams are coming up with their own responses to these problems. However, they occasionally ask us, the MITRE SAF, for help with particularly challenging problems. We've come up with solutions for 5 of the most difficult, which we're going to go into now. Aaron, do you want to let us know? Or actually, Will, do you want to let us know about this first challenge?
Sure thing. All right, so the first challenge we want to talk to you about today is container-aware baseline security guidance. That is, if I'm going to secure a container, I need to know what my target for security is. What am I targeting with my automation? I need some kind of widely agreed upon benchmark for security, hence a baseline document. Your teams might be familiar with CIS benchmarks, or maybe even DISA's security technical implementation guides. Those are the DoD government standard for security. The problem is, oftentimes we don't have that security guidance for whatever component I'm trying to harden, or the guidance was not written with a container in mind. This is similar to the problem that the industry faced when mobile and cloud deployments became more prevalent for software. Security baselines often assume that your software is running on a bare metal server somewhere that a human being assessor can sit down at and start typing commands into a terminal. It almost is never deployed like that anymore. Deployments are deployed into the cloud, they're delivered to your phone, they're delivered as part of a container microservice mesh, and so on and so forth. So moving forward, we need to be able to write not only just more benchmarks in general to cover the gaps in guidance that we can give to the wider community, we need to write better benchmarks that accurately reflect the technologies we use for deployment today, and they don't grow on trees. So before we talk about how we solve this as the MITRE security automation framework, let's give a little more background on the process for how baseline guidance has historically been written. Benchmarks and other baseline documents are created by a couple of subject matter experts who have to sit in front of a spreadsheet outlining generic high-level security guidance that they need to adapt line by line for their specific system component. As you may be able to imagine, it takes anywhere from months to years to do this if you have a big enough system that you're trying to write a baseline for. So if you have ever had to be the book boss for a document with multiple authors before, you may already have an idea of how many things can go wrong with a process like this. You may have experienced, emailing document drafts back and forth between your coworkers, and every single one of them is labeled the final draft for real this time. And suddenly you have a documentation issue that doesn't really have anything to do with the inherent difficulty of writing the documentation, right? It's just, it's difficult to keep track of your most recent copy, which is why we, as the MITRE Security Automation Framework, collaborated with the VMware Corporation to create the Vulcan security baseline writing application. We worked with VMware on this because VMware has to manage a large library of secure technical implementation guides for DISA. And they knew how painful the workflow was. So we took that painful workflow and we moved it into a web application that is actually built to do things like role-based access control, change management, version control, peer review, you name it. So now your subject matter experts can spend less time arguing over whose email inbox has the most up-to-date version of your draft STIG and more time doing their actual jobs, namely figuring out how to secure a system component. So over on the right there, we have a screenshot of Vulcan showing a guidance document that's being edited. You can keep everything nice and organized by project, and then you can open up your individual components you'd like to write content for. I can save my work to a web database and flag it for peer review. I can control the RBOC to give access to only my fellow authors. I can revert changes I don't like with a couple of clicks. I can track multiple versions of the same document, which is frequently something you need to do if you're publishing more than one version of a document. And finally, one of our favorite features that we added to this thing was an InSpec integration. We can write up the human readable guidance on how to secure a component and then move to a different tab in the same window and write out the automated code that would check that so that we can keep a tight binding between our original baseline guidance and the automation that we will use to enforce it. So in summary, the security community can work much faster and more effectively by using Vulcan to create new security guidance as well as their InSpec tests. We've seen experienced STIG authors be able to cut their STIG development time from something on the order of 18 months to 2 years, all the way down to 3 to 6 months, because they can finally focus on the actually difficult part of their job. Next slide. So a note about what we like to call container-aware InSpec profiles, which is what we want to be writing with our new benchmark tools, right? A few years ago, we started getting requests from our sponsors and partners to help them figure out how InSpec profiles should be written for containerized applications. So let's say I want to write an InSpec profile for scanning Red Hat Enterprise Linux, but specifically its containerized implementation, the universal base image or UBI. Do I need to write a whole new profile for that when I already have a perfectly good one for RHEL? No, I shouldn't have to. And luckily, because InSpec is extremely flexible, we can write profiles that don't care how the target is deployed. We can write in a simple if-else statement to catch if we are running this test inside of a container, and if we are, we can change our logic. So in this example we're showing now, we can completely skip a test if it's only relevant on a full host and not a container. So we recommend this pattern when writing InSpec code for your software components. You want to keep in mind multiple deployment strategies when you write your test code to ensure that one profile can be used anywhere in as many different deployment strategies as the underlying software would be. Hamdeep, back to you.
Our next challenge related to containerization is the sheer scaling issues you start to see in a containerized environment. Let's say we're splitting what used to be a monolithic legacy application into a whole bunch of microservice containers. Now you got so many containers, you should probably have an equal number of CI/CD pipelines. Suddenly, creating robust, thorough CI/CD pipelines becomes even more critical than it already was. You might even need bespoke testing for each container depending on what you're doing. We at the SAF have developed a few tools we believe helps with this issue. such as the SAF command line interface, or CLI. You can use the SAF CLI to normalize the results from all of your tools into OHDF, more on this later, for upload into Heimdall, your governance, risk, or compliance tool, or wherever you're storing these artifacts, to programmatically apply waivers for results that you've gotten permission from your ISSO to deal with later, to have thresholds that gate the success of your pipeline, to output nice summaries in your logs, and more. For those of you that leverage GitHub, we've made this tool available as an action as well. So now let's give an example of pipeline issues that we've run into on our team. Anybody who writes software for the Air Force will likely be familiar with Iron Bank, the U.S. Air Force Secure Container Registry. If you want to make your container available to military applications through Iron Bank, you need to submit it as an Iron Bank GitLab repository and watch it trigger an extremely thorough testing pipeline. Updating the repo in the registry to point to our newest release for our software whenever we pushed one out required making several very finicky manual changes. After a while, us engineers got tired of it and thought that this would be a perfect target to increase automation within our release pipeline. The team already had a pipeline in place for publishing releases, in this case for our Heimdall application, which is completely open source on GitHub. We could click release, wait a while, and then our container would eventually pop up in Docker Hub. At this point, it became a manual process to log into Iron Bank's GitLab instance, edit several files to reference our newest release in the repository for our application, and then draft a new PR in order to trigger their release process. Like with any manual process, steps accidentally got skipped or forgotten about due to human error or some sort of emergency popping up. However, we still aspired to keep our releases synced up so that our DoD users always had the latest and greatest features bundled with the most up-to-date and secure dependencies. Integrating with Iron Bank wasn't as straightforward as mirroring our GitHub repo inside Iron Bank's GitLab registry. Like I said before, we needed to be able to trigger its CI/CD pipelines to update, test, and publish images in response to our own application release pipeline. As you can see from that dotted line, we realized we needed some way to connect these two pipelines. And what better way to do so than with another pipeline? When we talked about this problem with Mike, we realized that we both had the same issue of wanting to automatically push up artifacts into Iron Bank. However, he had a solution, Sophos Factory, the pipeline building application. I'll turn it over to Mike to discuss Factory.
Thanks, Andy. So let's back up a little bit and talk about the genesis of the technology, and then we'll get into how we were able to help the SAF team solve this particular issue. So from a technology standpoint, this started out as Refactor, was a startup of mine. But even before that, I was a cybersecurity engineer in the Air Force, had various IT companies, and then came over to the software world and had multiple software startups. And I use a lot of different tools in the DevOps and the security space and realized that each of those products catered to their own domains and did not really provide a collaborative approach between teams, helping to cater to the full spectrum of technical talent between dev, DevOps, security, and ops teams. When I was creating this, it was something that I wanted to make sure that everybody could have fun with using, but also having the user experience to be able to come in and consume no-code pipelines that you probably hear a lot about, or low-code pipelines, and then being able to get as low-level or full code as you may hear into different tools and being able to use existing automation content. And another big piece of that is, in order to create the automation, you want to make sure that it's also use case driven, so that, if you're building something around compliance, where I'm trying to scan against, as Andy said earlier, a CIS or a benchmark or a NIST standard or so on and so forth, we were able to take existing tools out there like InSpec and the SAF CLI and package those up into pipelines for use, making sure that there was also an easy way to tie this into existing CI/CD and security platforms. So even things like GitHub, GitLab can be easily tied into and make it more of the interoperable middleware to augment existing systems and not just rip and replace, because the goal is that we wanted to provide automation as something that could be used across different teams and enable teams to also future proof. So in different use cases, a particular tool may be, or set of tools may be what your team is using now, but different teams may have different tools they want to use. And as you're introducing, new tools and new technologies or decommissioning tools and technologies, you have a way to create repeatable automation that can tie into other systems out there. Next slide. So where does Factory sit? It sits on top of existing systems, but it also supports greenfield or new automation that can tie into more of the brownfield or existing systems that are in place. The goal is to really let different teams, technical teams, bring in existing automation content so that they can support existing tools like Terraform and InSpec and the SAF CLI. And once those automation and tools and content are packaged up, they can be use case driven around different use cases like compliance, infrastructure automation. And the goal is that you can pick and choose each of those to create your own solution and be able to trigger those from where you want to trigger those from. Whether it's an existing system, your existing, say, GitHub instance, or tying it into other, security products, like being able to trigger response actions from, say, an MDR and XDR solution. So it really helps to cover the full gamut of different use cases. And another big value driver is to support execution in a hybrid environment. So both on-premise and in the cloud, so that wherever you need to run pipelines against in those systems, you can run them in your heterogeneous environments, knowing that there's always going to be change on where you want that automation to run, and being able to support both cloud and on-premise. And with the work we did with MITRE, we were able to build up pipelines to support the SAF CLI and InSpec, as I said earlier, and publishing those out to solution catalogs so that anybody can pick up that content and start using it immediately, because it's really about getting value as quickly as possible from automation content and making it easier to consume across the full spectrum of technical talent. I like to think about users in two buckets: the consumers and the producers. Not everybody's going to be able to produce automation, but if you have automation in a very consumable format, it will make it easier for other teams to not only use that automation, but also be a part of the automation journey and start learning new tools as we move things over to what I like to call IT as code. If the entire IT stack becomes software, aka IT as code, then we can also help empower cybersecurity and ops teams who've traditionally been working with, as somebody mentioned earlier, bare metal and tangible hardware. Now, if it becomes software, there's an easy path to be able to consume and start being able to create or use tools like InSpec or the SAF CLI, and then get into being able to add in building infrastructure as code and other use cases that help along the journey to where everything becomes code or IT as code. Will?
So, thanks, Mike, for that explanation of Sophos Factory. We were able to use Factory to set up a supporting pipeline that could trigger an update in Iron Bank within just a few hours. After that, it was just only a little bit more effort to integrate their GitHub action into our GitHub release process so as to automatically kick off that pipeline. Altogether, it was only a matter of hours to set up this integration, not days. And since then, it saved us plenty of time and headache. This is the sort of process we suspect will be common to application releases going forward. As every application becomes more modular and compact, our ability to control and link together release pipelines becomes ever more critical. Right now, most development teams, even DevSecOps practitioners with robust pipelines, tend to treat the pipeline as this giant monolith that can only be built upon with great time and effort. We need to overcome this way of thinking if we're going to keep up with all the automation we're going to have to do. And so I also want to talk about our next challenge, which is also a challenge of scale. What do we do about the large number of security tools we have available for container scanning these days? Like I was saying, in terms of just having all sorts of pipelines, you probably have a security pipeline set up as well. And you'll realize that within that pipeline, you have multiple scanning tools for multiple specialties. If you're going to call software secure, you need to have tested its source code, its runtime behavior, dependencies, configuration, and so on. Again, CVE testing and SBOM generation aren't sufficient. We'll call out InSpec here again as a great tool for scanning an actively running container much more easily than most other testing software that we've used, so long as you've got a transport for it. We don't often see testing tools that can adapt to containerized deployments like this. Now, you've got a whole battery of scanning tools, all of which are going to generate some kind of artifact or need to update a dashboard describing its findings. Furthermore, your testing tools may or may not even have the context you need to answer questions about your security posture. So now you've got another headache because you have 3 different dashboards with 12 different security formats and 20 containers that you need to do this for. If you want to answer the question, is my container image reasonably secure? It's scattered all over the place. So, one of the MITRE SAF's primary technologies to help address this is the OASIS Heimdall data format, which is currently in the process of becoming an OASIS International Data Standard. Teams should be able to keep on doing what they're already doing with all their different tools and run multiple types of scans. What we want to do is take all of these scan and security artifacts and normalize them down into a single format, OHDF, so that you can actually meaningfully operate on all of this data. If you normalize our data, every downstream action in the security lifecycle gets easier. Now you just need one dashboard, not 6, which means you can group all of your security data into one place and finally get a holistic sense of your security posture. If you've been using InSpec's JSON reporter, then you're already going to be very familiar with what an OHDF file looks like. OHDF is just a superset of that schema.
And Mike, this was one of the challenges that you were facing in the Sophos factory as well, right?
Exactly. We looked at all the different tools that we supported or we support currently and continue to support and package up, around Aqua Trivi and Twistlock and so forth, and needed some way to solve the issue of data formats being completely different between tools. And I think that's why we initially engaged with the SAF team, was to help us to work towards solving that issue. And I liked it so much that I volunteered and threw my hat in the ring as a co-chair of the technical committee at OASIS. And now we're driving the OHDF data format, and it's exciting to see other vendors engaged with the SAF as well. Very interested in OHDF because it is such a powerful way to take different data formats and normalize them and come up with a single way to utilize that data and then ship it off to whatever system that you are then using to visualize and do something actionable with it. Because I think that's one of the most important things about being able to standardize on a data format, is to be able to then use it to do something actionable, which is a huge part of the value of OHDF and what we've seen at Sophos.
Wonderful, thanks. Deep, I'll hand it back to you to tell us more about OHDF.
Sounds good. Here, you can see the wide array of integrations that we already provide with various security products, including Fortify, OWASP, SonarCube, DB Protect, Nessus, even AWS Security Hub. We're able to take their result sets as standalone files or via API integrations and then normalize them into OHDF. This effort to map all of these commercial tool formats into OHDF has been one of the most important ways we engage with the wider security community. Many of these tools you can see on the right can map to OHDF because we could work with their vendors directly. The SAF provides several libraries and tools so that you can integrate OHDF into your workflows as well. Side note, these integrations aren't all just into OHDF. OHDF is intended on being a data exchange format, so it's also possible to convert from OHDF to ASFF for viewing in Security Hub, to XCCDF for viewing in StigViewer, to HTML for viewing in your browser, and more. I'll also do a quick plug for the SAF's Heimdall application here. Heimdall is our security data visualization application that can automatically ingest all kinds of scanning artifacts and automatically convert them to OHDF on the backend. That way, you can put all of your security data in one place for a view of your entire system, a fully holistic view. We've got a demo version of the app up at heimdall-light.mitre.org. Feel free to take a look at our sample scans or even use it to visualize your own scan results. And now I'm going to pass it on to Will.
Thank you, Amdeep. All right, so far we've discussed scaling issues and our testing tools. Now let's talk about how challenging it is to do container-aware scanning. So we're going to build a bit on what we were talking about earlier with InSpec scanning capabilities. So if you have ever tried to assess a container against a standard benchmark, like a CIS benchmark or a STIG, you have likely noticed that many of the controls as written don't make sense for a container. Now, they're still there and they're still required. They still need to be assessed, but you're going to need to do some thinking to determine where you do that assessment. Some controls only apply to a container, some controls only apply to the host, but many of them apply to both. For example, many of the controls in the General Purpose Operating System Security Requirements Guide, which is DISA's Security Requirements Guide for operating systems in general, many of these requirements boil down to validating that FIPS mode is enabled, the Federal Information Processing Standards. You need to hit a certain benchmark of security and use certain secure algorithms. Now, this is a setting that you can enforce on most Linux operating systems, but here's the catch. FIPS is enforced at the kernel level on Linux. A container, unless something has gone horribly wrong, should not be touching the host's kernel and can't really change its settings. And you can set the FIPS flag inside your container all you want, but it won't really do anything to the host system. So what do we do about this? If we want to test our container for FIPS mode, we need to test that both the host and the container are set to enforce FIPS. So this is a pretty common pattern in container security, where the container cannot be any more secure than the host is, since ultimately a container is just a process running on the host with some window dressing on it. So we'll go back to our metaphor from earlier about there being no point in locking a door if you have a hole in your wall. So how do we make our testing tools reflect this? And for an additional example, we were asked by one of our government sponsors to take a look at the Red Hat 8 STIG and tell them how many of those requirements were applicable to UBI 8, the containerized version of Red Hat. It wound up being something like 200 controls were not applicable to a container, because as you can imagine, many of the requirements in a STIG have to do with kernel settings, which are therefore irrelevant to a container. So this is all to say, if you have only scanned your containers, you have not finished the validation process. You need your scanning tools to be able to see the entire stack from top to bottom, which again is where InSpec comes in. This is how we can finish off our validation process. So like we showcased in that security iceberg diagram from earlier on in this presentation, you have a full stack of software underneath your component, all of which will need assessment. And InSpec is an absolutely fantastic tool for doing this. Let's say that your application is running on a Kubernetes stack in AWS, right? This is great because InSpec on its own, off the shelf, can scan the web application container itself, the backend database, the EC2, the Kubernetes service, and even the whole cloud environment settings, all in one tool. We have resources for all of these things just sitting in default InSpec. That's why we write so much content in InSpec as part of the SAF team. However, with that said, there are things that InSpec can't do or isn't the best tool for doing. For example, if you need something like Fortify or OWASP Zap for assessing a running web application, InSpec's not really going to do that for you. So you need other tools to round out the gaps. That's where our normalization efforts come in. But InSpec on its own can handle most of the infrastructure for us, which is why we favor it so heavily. Amdeep, do you want to talk about maintenance challenges now?
Sure. Just because, so our next challenge is discussing how we maintain security over time. Just because your container was secure once doesn't mean that it's stayed secure. All sorts of things can have happened while it's been deployed that impact its security. A 0-day in a dependency could have been discovered. Someone could have accidentally or even maliciously changed the settings of a currently running application or service. Without data, it's impossible to know what the current state of your current security posture is like. The single data point that came when you created your container at the end of your pipeline isn't sufficient. You need to regularly assess your containers as well as the rest of your infrastructure stack, as well as described earlier, to ensure that everything has remained secure. Say that you find a container is no longer secure, you should take action depending on the source of the insecurity and the means through which you've deployed your container. For example, say that a dependency of a service running a container of yours is discovered to be vulnerable to a 0-day, i.e., a CVE scan that had passed when you'd originally created the image no longer passes when you test it against the running container. Ideally, you can treat your containers like cattle and cull them as necessary. After you stop the insecure container, all you should need to do afterwards is spin up a new one that has addressed the insecurity. You need to be able to continuously monitor your applications and environment, but determining where the deltas occur in your scan results can be difficult. If you normalize your scan results into OHDF and view them in Heimdall, you can easily track how your compliance changes over time. And I'll pass it back to you again, Will.
Thank you, Amdeep. Okay, so over the course of this talk, we've talked about the challenges we've seen as part of our work working with the government on container deployments, those being maintenance issues, tooling issues, scaling issues, and focus issues. Unfortunately, we don't have answers for everything. Shocking, I know. So let's talk about some of the challenges that we still need to address. Some of those challenges are purely technical. For example, one challenge we're currently working on is how to handle containers that are running on an abstracted platform. And by that, I mean, for example, how do I use InSpec to scan a container that's running on top of a microservice cluster? We're currently working with the InSpec developers to plan out a new type of transport that can access containers on Kubernetes nodes. Because right now, if I want to access a container that runs on top of Kubernetes, I can scan the Kubernetes API, the server, the nodes, all of that all day long. But if I want to reach a container that is running on top of Kubernetes, I would either need to use a direct SSH connection, which I really shouldn't be doing for a container, or I would need to use the Docker transport, which requires me to know exactly which Kubernetes node my container is running on. And that breaks the abstraction around Kubernetes. That is the whole point of using a microservice orchestration tool like that. So what we want is for InSpec to be able to use a transport to refer to, let's say, a Kubernetes pod or some other Kubernetes resource by name, so that I can scan applications on my cluster without having to break the abstraction layer. Another example is how am I supposed to use InSpec to scan a container at rest? That is a container image. This is necessary if we want to do something like scan an entire registry. This also allows us to have some sort of scan for containers that spin up, take an action, and spin right back down, sort of like what Amdeep was referring to in the last slide. Plenty of containers are ephemeral. such as like an AWS Lambda function. That container will only exist for as long as it takes to take its action. That's the whole point. So we need the ability to scan containers that are very short-lived in that fashion. Some less technical challenges. We are still building out OHDF. We're developing the 1.0 version of that schema specification. And so far, we've done so as the MITRE Corporation in collaboration with smart people at Sophos and at VMware and at Lockheed and all around the security community. But that does not mean that we don't want further collaboration with our peers and partners in industry. We also need to write up quite a bit of clarifying documentation that explains the differences and the interconnections between OHDF and other formats. And I mean, personally, I hate writing documentation, so that's going to be quite a bit of fun. So all this to say, we look forward and we hope that we can find some collaboration opportunities with the folks in the audience today. So if anybody here has ideas of how they can implement OHDF into their own projects, if you can think of a data format that it would be useful to you to be able to normalize into OHDF, we love external contributions. We love reading and reviewing your PRs. We love talking about OHDF. So please reach out and let's start a conversation. Okay, Aaron, do you want to close us off?
All right. Well, first off, I want to say thank you for everyone, and thank you for joining us today. As I mentioned earlier, all of the technologies and the capabilities that we've shown you today are open source on the MITRE GitHub and on the Sophos platform, and easy for you to adopt and use. I want to say thank you to all of our presenters today, Mike for joining us from Sophos, Andeep and Will for being such wonderful leaders in this area and helping our customers and our services do better. And if you want to reach out and communicate with us, you can do so directly via our email at saf@groups.mitre.org. You can reach out to us on the MITRE Slack, or you can just hop on our website and reach out to us directly through GitHub, through PRs or suggestions or issues. Mike, do you want to say anything?
Yeah, thanks, Aaron. And as for Sophos Factory and the stuff that we've done with the SAF team to get access to it, you can go to the link that's provided there to Sophos Factory and sign up for free community edition, which will enable you to use all of that content right out of the gate with all the open source tooling with InSpec as well as with the SAF CLI. And then you can also reach out to me directly with the additional contact information that's will be also included in the deck here that we will make available. Thanks, Aaron.
Thank you, Mike, and thanks, team.